Welcome to the first and only episode of Ben Tries to Teach Calculus, where I'm going to try and teach you the integrating method known as partial fractions. Partial fractions is used when you have a rational integral that can't be integrated normally, usually because of the annoying difference in the powers between the numerator and denominator. And so you have to break the fraction up into several fractions with lesser powers that can be integrated individually. Alright, the first example today is going to be 1 over x squared plus x minus 1. You can see that if you were to try and integrate that regularly, probably with u substitution, u would be the denominator, du would be 2x something or other, and then there'd be no du on the numerator to go along with it. So you'd probably be at a loss of what to do if you didn't know partial fractions. Right. The idea behind partial fractions is that you can break this up into smaller fractions that can be integrated on their own. So first thing you gotta do is factor the denominator of the original into something, well, as much as it can be factored. This one can be factored, I believe, to two binomials. Let me check that. X plus 2 and x minus 1. Yeah, good. That'd be embarrassing if I was wrong. Alright, so using partial fractions, we can break this integral up further into the sum of two smaller fractions. The thing with partial fractions is if it's just a binomial like this, then you only have to have one unknown in the numerator. So, two binomials, two unknowns, two fractions. And now we have this. And we have that it's equal to this. So, if this is equal to this, then this part inside is equal to this, which means we can get rid of the denominators by multiplying both sides by this. So, multiplying this by that, we get 1, and this side, the x plus 2 will cancel, and that, the x minus 1 will cancel. So we end up with 1 equals a x minus 1, that's not an x, plus b x plus 2. Yeah. Now all we have to do is figure out what a and b is. One of the ways to figure out what a and b are is to plug in a value of x that makes the other one 0. So, for this, say that x was equal to 1. Now we would have 1 equals a times 0 plus b times 1 plus 2 is 3. So 1 equals 3b, so 1 over 3 equals b. So b is going to be 1/3. Doing the same thing over here, say that x was equal to negative 2. Now we would have 1 equals a. Man, I'm worse at writing on this than I am chalkboards. A, negative 2, it's going to be negative 3. So then a equals negative 1/3. So now that we know what a and b are, we can put those back into the original and get a totally solvable integral. So a is a third, no, a was negative 1/3, all over x plus 2 plus 1/3 of b times all over x minus 1. That's really obnoxious looking, so you can totally just factor out a third, and you get, putting that over there because it looks nice, 1 over x minus 1 minus 1 over x plus 2. Now these are totally integratable however you want fractions. So this is solvable now, just like how you would want it to be. This would, using u substitution, u would be x minus 1, du would be dx, blah 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 blah. So this isn't a lesson on u substitution, this is partial fractions, so I'm not explaining how to do that. So that becomes natural log of x minus 1, believe there's absolute values on that stuff, minus 1 over x plus 2. Oh, wow, my bad. All times a third. And that is the basics on how partial fractions works. So apparently that was only 7 minutes and I need a few more, so I also didn't explain the other situations that could happen when you need to split into smaller fractions. Say your inside part was like this, and you factored out your x. Now you have x times x squared plus 1. This, just like before, would get you your a over x, simple, single term, just like binomial, one unknown. But this one, ax squared plus 1, irreducible quadratic factors need to have two unknowns, bx plus c, in the numerator. Which makes it slightly more complicated when you went out to solve for those two. Could be annoying. And if you have a binomial linear factor like that, raised to any power, 2, 3, I don't know, that has to be broken into things of decreasing power. So one of them would be the same thing, and the next one would be to the first power, breaking it down like that. Alright, so review. Linear factors like this only need one unknown. Irreducible quadratics, two unknowns with like that, in the form of a linear. Powers go down like that. So, review of what to do, partial fractions. First step, you got to factor the denominator. Then you got to separate it using these wonderful rules into smaller fractions. From there, you can then multiply the denominator, original one, across both, and then solve for all your unknowns in the numerators. Alright, the only last thing to say is sometimes if you have something like this, it doesn't really look like partial fractions. Numerator is higher power than the denominator. You have to use long division to divide out the fraction, and then you'll get whatever your value is. One of them will be integrable, and then the remainder, if there is one, will be what you then use partial fractions on. Kind of tricky. It's doable. Alright, so I hope that was useful. That's how you do partial fractions. Good luck.